Hello everyone, so my name is Eldad Marciano, work at Red Hat, software engineer at Red Hat. Today I'm going to talk about go-defer. So how many of you know what is a go-defer statement? Alright, awesome. How many of you use it often? Okay. How many of you know what is the corresponding keyword in other languages, or coming from other languages and use the corresponding keyword? Yeah, all right. So basically, I'm not gonna renew anything about the go-defer, but the most part is I want to raise your awareness when you do when you use the go-defer, and there is some edge cases we're gonna go over in the next slides. So we talk about the defer evaluation flow, how it's going to be evaluated, the defer order, and how we will use defer with direct and direct access VC pointers. So what it's all about. So all of us know that defer, we mostly use it to clean up some code, release resources, when we use locks and things like that, and how it's going to be evaluated. So defer is belong to a function scope. So we mostly use defer surrounding with some function. So as you mentioned, correspond to other languages like Python and Java. The keyword is finally. And again, the flow it will be evaluated with Go compared to other languages is quite different. All right, because we know that in Python, for instance, the finally belongs to try block scope, right? And in Go, defer belongs to a function scope. And let's see what the difference is. For instance, here we have some Python code. We're trying to acquire some lock. Then we try to release the lock in the finally block. This will happen immediately. Compared to deferring in Go, what will happen is we defer the evaluation of unlock the mutex. So what will happen is we get into the parser file function, take a lock, then we will defer the mutex, we do something, and then before we exit the function, we will release the lock. All right, so that's we defer the thing to before the function ends, and it's a bit tricky. Let's see. Let's go through some examples here. So we already know that defer belongs to a function scope. Here, for instance. We have very straightforward application. We go to the main function, then we have anonymous function, as you can see. The defer close will call to a close function. It will evaluate immediately. And the output will be something like this, like closing, which is what the close function will print. And then the I'm done message from the main function. If we will use it like this way, the naive way, what will happen is we will call the close function with defer, so it will be deferred to the end of the function, and then the I'm done message will print it to the screen, and then the closing message. And it's very tricky because sometimes our business units, if you want to support high-speed application performance, the order of the things you try to do is very important, because sometimes you don't want to spend some time and you probably want to release a lock before you do other things. So it's very important to bear in mind the order you do things. Also defer, use stack. Okay, so you can call multiple defer statements in your code, and it will be stack, last in, first out manner. For instance, you have these calls here, and you can see the stack. There is another example here. For instance, we are iterating over integers, And as you can see, what will happen is we'll get into the main function, start the counting, and the output will be something like this. First, it will print the messages, as you can see. Then it will iterate over the integers. It will defer them, the evaluation of them, to before we will exit the main function. Because of that, we see these two messages before we print the integers. So again, this is also helps to understand the concept of the defer stack. What will happen if you use infinity loop? It's very tricky. For instance, you want to have some listener, something very naive. You have queue. You want to fetch some queue from fetch some files from the queue. All right. So what will happen here? Any guess? What will happen here? We'll never reach the defer statement here. So that means we will never close the file. We'll never flush the writer. It's very tricky because we're in infinity loop. We are not in a function scope. So the defer statement will never evaluate it. It can cause memory leaks, file descriptor leaks, any other things like that. How we can solve that problem? With this way. What we will do is we'll take all the workload, or whatever we try to do with a defer to another function. We can use anonymous function, you can use a predefined function, and what will happen is we are in infinity loop, doing some things periodically, probably taking some item from a queue, use it with a function to wrap up all of this workload and finally evaluate whatever we want to evaluate. We did the first statement, and we are in a function scope, so everything happened properly. An example with lock, for instance. If we will not take whatever we want to lock to a separate function, what will happen is we will never release the lock. So we probably receive a panic or another problematic situation. Again, how we can solve that problem? Take away the workload into a separate function. Make sure we call the defer. We will release the lock with the first statement, and eventually our application will behave as expected. Another common example is when we use DB. We probably have some data access layer, and we map some objects, and we probably want to close the row once we complete our work we try to do with a DB query or something like that. Again, so with anonymous function or a separate function, we can make sure all the resources are released before we leave the infinity loop. So again, it's very important if you want to support high concurrency or high-speed application, and also if not, just to make sure you're not leaking any resources like memory, hanging application because you're locking for a long time your application, file descriptors, things like that. So again, remember that in infinity loop or in a loop without a function scope, the defer will never evaluate it. So some thumb rules. Again, defer belongs to a function. We already know that. Defer stack the calls into some stack, last in, first out. We also know that defer inside infinity loop will never evaluate it. And another thing is we want to make sure we will use defer carefully with the sleep. Not a sleep, like a sleep, it's an example, like when we use defer in a periodical manner. Okay, for instance, here we have some sleep. In the Python world, what will happen here, the finally statement will evaluate it immediately, each iteration. All right, so then you see we print the counting message, then each iteration we print out the screen, the sleep. And finally, the done message will print to the screen. So this is the very expected behavior. Here, for example, in Go, the defer will evaluate it when we exit the function. So if you want to, again, do something with your defer statement and you want to make sure it will evaluate it immediately, make sure it's wrapped up in the function. So some defer gotchas. This is a nice example. Actually, most of the examples here are taken from some blog post that some guy named Inak Gumuz has posted. So I think some of the examples from there. Also, there is another blog post. I put the reference in the last slide. Here, if you want to defer some object with direct access, in the left pane of the screen, you can see we have some car model, and we instantiate it with some DeLorean model. What will happen? The defer will be the DeLorean model because we take a snapshot of the first instantiation object. At the right side, what will happen since we are using a pointer, we can make sure we can dynamically change the evaluation of the defer statement. So it's another thing we should care about when we use the defer statements. So again, some reference to documentation and blog post regarding the defer statement. You can, I strongly suggest you guys to go over them. There is a nice examples out there. And also you can search for another defer gotchas over the net. And this is the most important part that I want to cover and raise your awareness when you use Go defer statements in your application. And this is the last call. I don't hold you too much. And that's it. Thank you very much.